So we got minus 2 though.
Oh, do you want to talk about?
What?
It was like this one guy.
That one guy did this, he was like, this dude's by himself. I was the short one. I think it's fucking really good. All the other, dude, we were all rooting for the East Coast kid. Mr. Keys was, he's a basketball player. Yeah, yeah, yeah. He did dance. He didn't slide on the table, he like went. Also, let's do that first. It's an esports. And whoever to the kid, you know, advice when she over that table. The guy seems really. I don't want to hang out with that guy. You're not hear what he said, man. I like Tues.
Like, I want to learn, like, keep texting the other day.
Okay, guys, page 20. I want us to finish off this page together. Your quiz is tomorrow, and give you guys another few worksheets for us to start if we finish with this. And then you guys also picked up a half sheet. I have some work problems for us to practice with that I wasn't able to fit onto the first review worksheet. But on page 20, we did number 8, A and B. Doing operations with vectors. We just involve the coefficient if needed, and then add or subtract accordingly. Now, let me review a bit with part C and D. Are any of the vectors orthogonal? So this is on your summary sheet, which is on the back of your calendar. It says that two vectors are orthogonal or perpendicular if their dot product is equal to 0. Dot product is where we take two vectors in component form, and then we pair the horizontal components together, we pair the vertical components together, and we add them. Okay. So again, dot product is just A1, A2 plus B1, B2. And if their dot product is equal to 0, we know the two vectors are orthogonal. If the dot product is not equal to 0, then we know it's definitely not perpendicular. So go ahead and try part C. So we'll do dot product of U and V, find the dot product of V and W, and the dot product of U and W. See if any of them produces a dot product of 0. And you get to use your calculators tomorrow on your quiz as well. Okay, so U dot V is equal to 29. Dot product of U and W is 9. dot product of V and W is 3, and none of them equal to 0, so we know none of the two vectors are arranged in a way where they're 90 degrees intersecting with one another. Okay, for part D, we want to use that the cosine formula, which I will provide for you on the quiz. I'll give this formula to you. I'll find the angle between the two pair of vectors. So I just want us to find the angle between U and D. That I want us to have to do it for every one of them, because none of these three are orthogonal. So again, the rule that we use for angle between two vectors is go through a couple of steps. We got to make sure we find the dot product in the numerator. Denominator, you're going to find the magnitude of the two vectors separately, multiply them together, and then you're going to get this down to a fractional value, and then we do inverse cosine to solve for theta. Now, once you solve for theta, you don't have to worry about first quadrant, second quadrant, 180, 360, whatever you get for theta is your answer. Okay. And so try part D, just vectors U and D. Yeah. Okay, so pick vectors U and vector V, do the dot product. So 5 times 1, we pair the horizontal components together, pair vertical components together, add the two together, we get 29. And in the denominator, we take each of the vectors separately, and we find the magnitude, square root of a squared plus b squared. Get that all down to a decimal value, and then just do inverse cosine. Make sure you're in degree mode. Theta is 3.945 degrees. Right, any questions with number 8? So we need to be really comfortable going back and forth from component form to magnitude direction, but then also from magnitude direction back to component form. So again, on your summary sheet here, as a reminder, I feel like we're pretty comfortable going from component form to magnitude and direction, because we know Pythagorean theorem will get you to your magnitude, and your direction is just inverse tangent with adjustment with either 180 or 360, depending on the quadrant. But if you were given the magnitude and direction, make sure we also know how to get back into component form. And the formula is this, okay? It's magnitude times cosine theta for the horizontal component, and then it's magnitude sine theta for the vertical component. And either you memorize this or you understand how to arrive at these. So for instance, I'll draw this triangle here. We know that if you're given theta and the magnitude, I'll just say that magnitude for vector v. And if I ask you to solve for x and y, you will use sine and cosine, right? Because you know that cosine of theta is equal to x over the x over the hypotenuse, right? Xj is the number of hypotenuse. So if I solve for x equals magnitude times cosine theta. So that's where this formula comes from. Likewise, sine of theta is opposite over hypotenuse. Oops, sorry, y over magnitude. And if I want to solve for y, I say y is equal to the magnitude sine theta. So either you memorize this or you know how to arrive using SOHCAHTOA. Okay, so let's try number 9, 10, and 11. You have your magnitude, you have your theta, then magnitude cosine theta will get you your horizontal components. Magnitude sine theta will give you your vertical component. And you're just entering exactly into the calculator. There's no need to make any adjustments after you use this formula. Now, some of the calculators may not give a decimal value. An exact value in radical form, but that's okay. As long as it's equivalent to that value to 3 decimal places, I'll accept it. Okay. So, yep, your calculator produces a decimal value. Leave it in that form. Okay, try 10 and 11.
So we should prefer the answer in that, I guess.
Depends on whatever your calculator. Some calculator, the 36 Pro gives the radical form. I don't think the graphing calculator does that as well, so I'll accept either. All right, once you know what formula to use, it's pretty straightforward. I do want to walk through 12 and 13 with you, as well as a few more word problems. Now, getting that practice translating those words into something that we can work with algebraically and numerically.
Not if it's decimal or.
Right, yeah. Okay, everybody good? 9 through 11? Okay, let's walk through 12 together. So 12 says a boat is traveling west at 25 miles per hour. The current is moving south at 3 miles per hour. What is the boat's resultant speed and what's the direction of the boat's movement? So the boat is trying to travel west. The current is pushing us south. We can kind of imagine that those two different directions is going to push the boat in a certain direction. So as a reminder, here's a compass. So a boat is traveling 25 miles per hour, traveling west. So let's create a vector for the boat. And the current, we'll create a component form for. So what do you think is component form for the boat? Traveling west at 25. Okay, so we know left is west, so that's negative. And then the vertical component is what? So it's just traveling west. 0, yeah, so purely traveling west, that means it's not going to have any vertical movement. It's just going straight to the left. And now the current is moving south at 3 miles per hour. What do you think as a vector we can create for the current? 0, -3, right? No horizontal movement. It's just going down, and down is negative. Right? What is supposed to result in speed? So what do you think we can do with these two vectors? Not the dot product. Not subtract.
You do the thing you did it on D, that formula.
Well, think back on this, right? If I were to ask you to put two vectors together, you would add them, right? So that's the same thing here, right? If I want to draw these two vectors, I would draw one, and I would draw the other, and then I would add them together to figure out what the resultant is. So anytime I want to find the resultant between two vectors, I'm always adding them. Okay, so the resultant vector is just vector B plus vector C. The nice thing about component form is that everything is lined up. So the horizontal will be with the horizontal, vertical with the vertical. So what's my resultant vector? Yeah. So either I draw this out or I can just use my formulas to figure out exactly what the speed is, or Pythagorean theorem, hypotenuse, and then the direction. So speed is just the magnitude of my vector. And I never have to worry about negatives because I know everything's going to be positive once it's squared. And what can I use to do direction? Inverse tangent. B over A. Okay, any adjustment that have to do with this inverse tangent? Which quadrant is this vector getting pushed into? Third quadrant, right? So what do I do with this degree measure? How do I get this in the third quadrant? Plus 180, yeah. Because you know that second and third quadrant, you got to play with 180, but if it's fourth quadrant, you'll play with 360. If it's first quadrant, you leave it alone.
Do you want us to write it out like this? Like, I just like drew a like small triangle and then did Pythagorean.
That's fine. Yeah. I'm always thinking a Pythagorean theorem, but you can definitely draw this out as well. So we did.
Just
You drew.
anywhere we can figure it out.
Mhm. Because if I think about this vector, right? Left 25 and down 3, which quadrant is it in? Third quadrant. So I got to produce a degree measure that's also in the third quadrant. So I got to do plus 180. That's my reference angle, right? Yeah. So I'm always, your calculator will always give you the reference angle, and you got to do something with it if it's in a different quadrant than the first quadrant. Okay, Alvin pulls a sled through the snow with a force of 50 newtons at an angle of 35 degrees with a horizontal. Find the magnitude of the force. Okay. So magnitude requires us to, I'm sorry. This is, let me change this here. I meant to say, find the horizontal vertical components. So this is working backwards, similar to how we were dealing with number 9. You're given the magnitude, you're given the degree, and you're just going through and using cosine and sine to get back to your component form. Just like 9 through 11. Any question with 13? 14 says draw and label a vector with a magnitude of 15 meters at a rate of direction of 230 degrees. Okay, which quadrant is that in? Third. Okay. So I'll just, doesn't have to be accurate. You just have to show that direction. And then just label your vector. And I'm also going to extend this problem a bit. Find the horizontal and vertical components. So just like 13, get into component form. Okay, I gave you guys the half sheet, or you guys picked up the half sheet. because I wanted to do just a few more of these word problems so that you guys can get some more practice before we go on to the other worksheet. So I'll put it up once you guys had a chance to check your answers here. So you can call this 15 and 16. 15, I made it similar to 12. And then 16, I made it similar to 13, just so that you can get some practice. Okay, so you don't have to copy down the problem, you can kind of just read it and kind of show your work. So here's 15. You picked up a half sheet, or you can use any where you want to do a problem. Now, this is a separate problem. It's not on in your packet. If you need some scratch sheet, you can pick up a scratch sheet, or you can put it on any empty space that you guys have. Okay, so Kaya is swimming due west at a rate of 1.5 meters per second. Strong current flowing due north at a rate of 1 meter per second. Find her resulting speed and direction. Yeah.
Okay.
There's the two directions.
I know that, but I will, that makes sense, how to solve it.
Yeah, if you get the right answer, it's okay, that process. So just like number 12, you're going to create your two vectors in component form, add them together, and then you're just working with your resultant vector, right? Because then you can use Pythagorean theorem to get the magnitude, use inverse tangent to get the direction. So you can create two vectors, right? K for Kaya and C for current. So what component form can we create for our swimming? He's swimming due west at a rate of 1.5 meters. What would you say? Is this due west? Is that a horizontal or vertical component? Horizontal. It's going left, so we got to make it what? Negative. Right, negative 1.5 comma 0. And the current is flowing north, so what's the current vector going to be?
Vertical constant.
So what's our vector? What's our component form?
0, 1.
0, 1, yeah. Add the two vectors together to get your resultant vector. And then you're just working with the resultant vector to get your direction and your magnitude. Think about that, this vector here. Which quadrant do you expect that vector to end up pointing in?
Two.
Second quadrant, right? So you gotta play with 180 to get that theta to be something that you expect it to be. Okay, everybody okay with 15? Okay, here's 16. Again, it's not in your packet, but I have it up here on the board. Everybody go with 15? Okay, so vector 1 is 15 meters per second squared at 60-degree angle to the horizontal. And vector 2 is 9 meters per second squared downward. Determine the magnitude and direction of the resulting vector sum. So gotta create component forms for both vector 1 and vector 2. And then you can add them together. Okay. Vector 2 is going to be a lot easier because it's going in one of the easy directions. But if something is not pointing in direct east, west, north, to south, you gotta get it into component form by using sine and cosine. Okay. So see if you can get vector 1. You have your magnitude, you have your direction, get it into component form. Vector 2, I think, will be easier to do the component form. But either way, we got to add the two together and then same thing. Sine and cosine to get Pythagorean theorem and inverse tangent to get the resultant vector. Or to get the information from the result vector. So with vector 1, I got to get it to component form because it's not pointing at a nice east-west, north-south direction. So magnitude times cosine 60, magnitude sine 60, that will give me my, because what our goal is, anytime we're dealing with multiple vectors, we're always trying to figure out what is horizontal, what is vertical, because then we can add like terms with like terms, right? We don't want to be adding a vector that's pointing a different direction with a vector that's horizontal and vertical. So if we can get everything separated into horizontal and vertical, then we can add like parts and figure out exactly where the resulting vector is pointing in. Okay. So this is my exact value, but if you have a decimal version, that's fine as well. Now, vector 2, I think is easier to produce. It's 9.8 meters per second square downward. So how would you create vector 2?
15.
Well, let's just create vector 2. We'll doing it separately. So what is the component form for vector 2? 0, comma. Good, -9.8, because we're going south, yeah. So now we can add these two together, create the resultant vector. So anytime you see resultant vector, that just means I'm adding my separate vectors together to get. So once I add my two vectors together, then I can go through Pythagorean theorem to get to my magnitude, and then inverse tangent to get to my theta. Okay. Which quadrant is my resultant vector pointing in? One, right? So that means whatever theta value you get, do you need to make any adjustments? No, yeah. So first quadrant, your reference angle is your theta value. Okay, for the next 5 to 10 minutes, if you guys can start worksheet 2, Worksheet 2, this is a good way for you to practice for your quiz. This is what your quiz will look like, front and back. I will give you the cosine theta angle between two vectors formula. The key is attached. Let's see if we can try to get through the first page. Got the bill schedule on the board here. Dash the key so that you guys can kind of progress through and see how you do, and hopefully everything is clicking together in terms of your comfort level for the quiz tomorrow. Keep working for 5 more minutes, and then I'll let you get your phone. And remember, if I gave you two order pairs, there is a formula to create that vector in component form, right? It's x2 minus x1 and then y2 minus y1. So I think it's a good idea to look through your summary sheet, make sure you're comfortable with each of those topics. Again, true bearing is not going to be on the quiz. Okay, so everything up to number 9. And then I will give you the angle formula between two vectors. So make sure you study for your quiz, work through the worksheet. I will be available tomorrow morning if you have any questions. But I'm just going to answer any specific question you guys have. So whoever comes here, I'll be available to help with any problem that we go over. Okay. All right, I'll send out a reminder this afternoon. Make sure you bring your calculator and review your formula. All right, don't forget your phones.